So today's topic is alternating voltage applied to a capacitor. So this is the circuit, capacitor and AC source. This is V is equal to V naught sine omega t. This one is C. So we know that from here we have to find out what is the current. So V is equal to V naught sine omega t, and we know that V is equal to Q by C. Okay, so already you know that V is equal to Q by C, right? Q by C is equal to V. Q is equal to VC formula. C is equal to Q is equal to V into C formula. So Q by C is equal to VC is the capacitance. So we can write V is equal to V naught sine omega t. Now from here what we'll get, so Q is equal to V naught into C sine omega t. Now to get the current from here, you have to differentiate both the sides with respect to t. So I is equal to, we know, dq by dt. So d by dt, that is V naught C sine omega t. So if we differentiate, we will get V naught C cos omega t into omega, or you can write from here V naught by 1 by C omega cos omega t. So cos omega t you can write in this way. So cos omega t you can write sin omega t plus pi by 2. So this is your I will become V naught by I C omega, then sin omega t plus pi by 2. So we can compare this one. I is equal to I naught sin omega t. So you can get I naught will be how much? I naught will be equal to V by 1 by C omega. Sorry, V naught by 1 by C omega. You can get I naught from here. So this is the peak value. This is the peak value of alternating current. Peak value of AC. Now if I want to do the phasor diagram and the time diagram for this, then what we'll get? First we'll draw the time diagram. Time diagram will be like this. This is V and I. So this one was voltage. This is voltage. And as well as you can draw the phasor diagram from here. So this is the V naught. You can exactly make it equal here. So this is V naught. See, I naught, I is equal to I naught sine, you can write I naught sine omega t plus pi by 2 also from here. This is separate. So see, current I naught is pi by 2 times, it is leading. That means you can write it here in this way. So if we draw a line again, draw a line like this way. So your current will be in this way. So this is your current. Your current is I. I can extend from here also. So this one is I. This is 0. This one is pi by 2. This one is pi. This one is 3 pi by 2. This one is 2 pi. And this is your time. phasor diagram also will be like this. This is I naught, this one is 90 degree, this one is omega t. So from here you can say that the current leads the EMF by an angle of pi by 2. So you can write current leads leads the EMF by an angle pi by 2. Now next one is that this one 1 by c omega. What is 1 by c omega? 1 by c omega is called capacitive reactance. Capacitive reactance is xc is equal to 1 by c omega. So same like that, it will be also the SI unit of this one is ohm. So you can write xc is equal to 1 by c into 2 pi nu. So if you draw a graph between nu and xc, the graph will become like this. So another question is that in case of AC, first we will take in case of DC. In case of DC, frequency is 0. So xc will be 1 by 0. 1 by 0 means infinity. So that means the DC will not be able to pass through the capacitor. But in case of AC is having some finite value. So that is why the value of xc will become very smaller. So AC can easily pass through the capacitor. Okay. So you can write here also. At this point you can write x c is equal to infinity if nu is equal to 0, because 1 by 0 means 1 by 0 is infinity, and xc is equal to small value for nu is equal to finite. So for some finite value, xc value will become very less, or you can say the AC will pass easily through the capacitor and DC will not be able to pass through the capacitor because DC frequency is 0. As the frequency is 0, you can say 1 by 0. 1 by 0 means it will become infinity. Okay, so thank you very much.